So I'm now going to go over section B of your paper, because I just couldn't quite finish it earlier. So section B of your paper, these are the questions that you write on a separate answer booklet provided. I think that's kind of so that you can look at the question and do the paper beside it versus having to turn and do it on the back side of a sheet of paper. So you can see the question as well as writing stuff down, which of course is very helpful. So let's dissect the first question. So I can already see it's looking like calculus. It's a function there. There's often a lot of calculus in section B. So the function is defined by h of x equals 2x e to the x plus 3, where x is of reals. The following diagram shows that, let me just highlight that, the following diagram shows part of the function, local minimum at point A, so this is a minimum at point A. Find the value of the y-intercept. Okay, well, the y-intercept would just be when x equals 0, so the y-intercept would be h of 0, which is going to be 2 lots of 0, e to the 0 plus 3. Well, even though e to the 0 will be 1, because we've got 2 times 0 before it, all we're left with here is 3, and so therefore my coordinate would be 0, 3. Part B, find the differential. So h of x is 2x e to the x plus 3. So if we differentiate this, and this is the key part here, technically we have two functions. We've got a function u and a function v. And so if we label this one as u, then u dashed will be just 2, and if we label this one as v, then v dashed is just e to the x. And then we apply our product rule. And of course the 3 cancels out, so h dashed of x would be u dashed v plus v dashed u, which is the same as 2 e to the x plus 2x e to the x. Part C, hence find the coordinates of A. Well, if A is a local minimum, that means that we need the differential h dashed of x to be equal to 0, where x is the coordinate, the x coordinate of A, and so therefore we need that 2 e to the x plus 2x e to the x equal to 0. Here you've got to be super careful, because the issue here is that if we factorize out we can factorize out 2 e to the x and then 1 plus x, that e to the power of x can never be equal to 0. If you think about that, even giving it like a power of 0, if you did e to the power of 0, you get 1. If you get e to the power of negative 1, you get 1 over e, which is going to be just a very small number because it's 1 over 2.7, and so on and so forth. Even like e to the negative a million isn't quite going to get you to a 0. And so the key part here, and I think this wasn't necessary on the mark scheme, but it could have been, is the fact that either you've got 2e to the x equal to 0, and then, however, e to the x cannot be equal to 0, yeah? Since like 0 is not equal to e to the x. You can't just cancel out the solution, because an easy thing to do would have been just to cancel out solutions like this, but you can't do that. You've got to sort of think of them and understand what they're saying. I'm going to now actually take this below, give more space. So the other solution is that 0 equals 1 plus x, because one part of that has to be 0, and that one does work there because you get x equal to minus 1. So we need to find the coordinates of A. So if we plug in minus 1 into our function to find our value for y, we would get h of minus 1, which is going to be 2 lots of minus 1 e to the minus 1 plus 3, which is the same as 3 minus 2 e to the minus 1, and you could leave it at that, or you could do, minus 1 as 1 over e. And so therefore your coordinates of the point A would be minus 1 and 3 minus 2e to the minus 1. Part D. Part DI. Okay, find the second differential. Well, the first differential was 2e to the x plus 2x e to the x. So the second differential, x, is that this here really is just going to give us 2e to the x. And the second part here is just actually h dashed of x. Do you see it's a repetition of what we got above? It's exactly the same as this here. If we differentiate, it's going to get us to that because it's exactly the same as this here. Or let me just show you further up. It's just the same as our first function because we're just differentiating that again with the product rule. And so in fact, what we get here, we would just get h double dashed of x is equal to 2e to the x plus 2e to the x plus 2x e to the x, and so therefore we get 4 e to the x plus 2x e to the x. Finally, factorising the 2 out and the e to the x out, we get 2e to the x on the outside of 2 plus x, like they've got in the question. Oh, they've left the 2 inside. Okay, fine. You can leave the 2 inside if you like. All they've done is factor out e to the x. So therefore we get 4 plus 2e to the x, as given. Second part is find the points for where it is concave. Up, I think that's quite helpful, saying something's concave up versus convex, because then you realise, oh, it's up, like that. So that's what we're looking for. We're looking for the u. The way I like to think about it, if it's convex, is the concave is the one that looks like a cave, dark cave, whereas convex is just the other one. But they've put down concave up, so they've saved you the hassle there. So concave up, we're looking for all the points on the curve where it's going up. At this point here, technically it's going down, but it's just a very small slope. So the key part here is we need to find our inflection point. Well, the inflection point is going to be when the second differential equals 0. So we've got e to the x 4 plus 2x. That should be an x. And so by the same logic, e to the x cannot be equal to 0. Cannot be equal to 0, and so therefore we've got 0 is equal to the other part, 4 plus 2x. And so therefore x would be minus 2. Well, that's the inflection point. And this is a part, so the inflection point's going to be about there. Minus 2. This is the part where a lot of people put down just the wrong inequality. And I had to think twice about it as well. Is it a greater than or equal to, or is it just a greater than? And the inflection point is technically neither concave up nor concave down, so therefore you cannot include it. I gave you the mark, but that was awfully generous. In reality, all you need to do here is write down that x is greater than minus 2. And if you think about that on your graph, well, from that point onwards, it's going to go up, because it's neither concave up nor concave down at an inflection point. And so just in future, note that it's a strict inequality. Okay. Question 8. This was by far the hardest question on the test paper. This, in fact, was given to the students last year on their paper 1, and so it has been seen before. And it wasn't some question that I drafted off some A-level spec paper from years ago. This is a genuine IB past paper question from last year, so it's well worth understanding what's going on here. In fact, I gave you in your trigonometry test not so long ago almost identically that question there, and so I'm glad that most of you got that. But it's quite uncommon, but it did turn up last year, and so that's why it's good that we did it in our mock paper. So they want you to find the acute angle. Now they say consider the acute angle theta such that cos of theta equals 2 over 3. So in part A, we're given that cos of theta equals 2 over 3. there's a couple of ways to find sine theta here. One way to find sine theta, and I saw some people try this, is that sine theta, well, we know that sine squared theta would be 1 minus cos squared theta, or let's do that step by step. Sine squared theta plus cos squared theta equals 1. If we then rearrange that, we get sine squared theta is equal to 1 minus cos squared theta, and then square rooting both sides, sine theta equals the square root of 1 minus cos squared theta. That's definitely a possibility for doing this question, and I'm going to do the alternative method side by side here, but let's do this one first. So in this case here, sine theta will be equal to the square root of 1 minus 2 over 3 squared, and so therefore we would get the square root of 1 minus 4 over 9. Well, 1 minus 4 over 9, if we write 1 as 9 over 9, we're left with 5 over 9 square rooted, which just leaves us with the square root of 5 over 3. The alternative way to do this would be to draw the triangle out. So if we know that theta is that, we know that cos is the adjacent over the hypotenuse. And so the adjacent here would be 2 and the hypotenuse would be 3. So what would the missing value be? Well, it would be the square root of 3 squared minus 2 squared, which is the square root of 5. And then you know what your opposite value is, and so you know that sine theta is your opposite over hypotenuse, and so all you're left with is square root 5 over 3. So whichever method you found easiest, I saw people attempt both in their test paper, so it's really down to you. Part II, they wanted to find the sine 2 theta value. Well, you gain a mark just for putting down that sine 2 theta from your formula booklet is cos of theta 2 sine of theta cos of theta, or cos of theta sine of theta, because it's commutable or commutative. And so we've got all our values here. We know that cos theta is 2 over 3, and we know that sine theta is square root 5 over 3. I kid you not, like 4 people put down 4 square root 5 over 3. However, you've got 3 times 3 on the bottom here. Don't forget that. You can't just get rid of one of the 3's just because they're the same. If you multiply fractions, you multiply both the numerators and the denominator together. In fact, I would say like our fraction skills in terms of adding and subtracting fractions, multiplying and dividing are fairly weak, and it's something that in general we should all be working on, because it's just crucial. Those sort of mistakes just cost you marks you don't need to lose. And so if you multiply all the denominators together and all of the numerators, you'd be left with 9 on the bottom and 4 square root 5 on the top. So part B. Show that B equals 3a over 4. So 3a over 4. Well, let's look at our diagram that they've given us. You can assume, because they said this in the top part of the question and not in part A, if they put it in part A, it would only refer to part A, but because it's separate at the top of the question, you can assume that this applies to all the other parts of the question. And so in fact, our value for cos theta is still 2 over 3, and our theta here hasn't changed for part B of the question. Otherwise, it would just be impossible to complete. So if we look at that second question, what they're giving us is they're giving us A, B, theta, and 2 theta. Well, straight away I can see here that these are opposite to each other, and so we can apply our rule that we know for this, which is our sine rule. And so our sine rule is that sine A over A equals sine B over B. Well, in our case here we've got sine theta over sine theta over B equals sine 2 theta over small a. And then we know what sine 2 theta and sine theta are, In fact, we could make this even easier by just flipping it. If you cross multiplied the whole thing, you would find that this is identical to if you were to just flip them around. Let me flip them around. It just makes it slightly neater. So I'm going to use b over sine b equals, but small b really, isn't it? Small b over sine b, and then small a over sine a. And so my values here would be b over sine theta equals a over sine 2 theta. And then we'll just use our values from part 1. So part A, we found that our value for theta was the square root of 5 over 3. And we found that our value for 2 theta would be 4 square root 5 over 9. And so, let me write that over here. And so if I multiply through, I think first thing I'm going to do actually is to flip the fraction here. So flip both fractions. So in other words, if I'm dividing by that, it's the same as flipping the fraction and multiplying, because b divided by square root 5 over 3, keep, change, flip, keep, change, flip, or KCF, or Kentucky Chicken Fried, whatever you want to know it as, would be b times 3 over square root 5. And so you would just get 3b over root 5. And then on the other side here, we would get 9a over 4 square root 5. Well, because there's square root 5s on both sides here, I can cancel those. Both divided by square root 5. And so all I need to do is divide by 3, and so therefore b would be equal to 3a over 4. Kentucky Chicken Fried. Okay. There's another section to this. This is, as I said, this is just a bit of a mammoth question, really. Part C. I actually struggled most on part C, and I'm going to explain why in a second. But the value just didn't seem to check out for me. But sine of CAD, so CAD is this here. This is CAD, or the angle at CAD. So find the value of sine CAD. So BA is extended to form an isosceles triangle DAC. So DAC. So from that, we can assume that this here would also take the value B. Find the value of sine CAD. So again, first thing I'm thinking is I want to apply my sine rule, but in order to apply my sine rule, I need to find this value here, because it's exactly the same as the other case, that we need to use the opposites, like that. And if we've got two sets, we can apply our sine rule. So how do I find that value for my question mark? The way I went about this is that I assumed I took half of it. I knew it was an isosceles triangle. I took half here. And then I took that as a right angle. And because I've got my value for B here, I can find that this here would be, well, if you almost flip that round, the triangle here that I'm left with is like that there, where there's theta, and then this is B. And so what my value of my opposite be? Well, the opposite, using SOHCAHTOA, would be B sine theta. And so that's all I get here, B sine theta. And then my other value here would also be B sine theta. But let's double check, well, what was our value for B sine theta that we found earlier? Applying what we used in part A. Well, sine theta had the value square root 5. No, it's cos theta, sorry. Cos theta had the value that we found earlier, and that value there was 2 over 3, so we know that this is 2 over 3b. And so if we know that that's 2 over 3b, we can assume that the whole length of the side here would be 4 over 3b, and then we can try our sine rule on that. And so our sine rule for this case here would be that sine of CAD is what we've just found, 2 lots of this, because it's that length and that length to be opposite to CAD, and so that'd be 4 over 3b. So we get 4 over 3b equals sine of theta over my value for b. So over b. And so therefore, if we cross out our b's because they're featured on both sides, what we're left with is sine of CAD. And it's worth putting that on just to signify that's what my angle is 3 sine theta over 4. And so sine theta we've also found before as square root 5 over 3, and so we've got 3 over 4 lots of square root 5 over 3, and so what we get is we get square root 5 over 4. Was it square root 5 over 3? I feel like I've made a mistake here again. Okay, let me just quickly double check. 2 over 3 times b cos theta, isosceles triangle DAC, with the angle at D being theta. Okay, 2 over 3, 4 over 3. 4 over 3. 4 over 3 divided by 4 over 3, same as times it by 3 over 4. 3 over 4 is that. Okay, last time I got a 9 in there somehow. That's what I'm thinking through. Because I did sit this paper last year as well when I did it with the students, so I can kind of remember that. Okay, give me a sec. I don't think anybody got this question, but I can sort of double check some of the notes of mine on it. 3 over 2 times C. Can't see a mistake in my working yet. I didn't really want to re-record the video. Well, let's just take it as that for now, and let's see how we go. It could be right. I might have made a mistake earlier. So, if sine of square root 5 over 4 is in fact, sine of CAD is square root 5 over 4, well, therefore the area of our triangle DAC, well, we know what our base is if we just redraw that triangle. So it's part D. Our base here would be 4 over 3b, and our height is what we need to find out. So we've got a triangle up here that we created, and so we know that our triangle would have height b sine theta by the same extension of the triangle that I was using earlier. So this is b sine theta. But sine theta we found out was the square root of 5 over 3, so that's the same as square root 5 over 3b. And that's my triangle there. And so in order to calculate my area for this triangle, I need to do a half base times height. And so in this case here, that there was theta, wasn't it? Yeah, theta, and therefore by extension this is theta. Half base times height would be a half 4 over 3b times square root 5 over 3b. And so what we'd end up with would be 2 square root 5 over 9b. But we're trying to find it in terms of a, and the value for b that we found was 3 over 4a. And so if we substitute in 3 over 4a into this instead of b, we would get 2 square root 5 over 9 times 3 over 4a. Bit of manipulation here. 3 in the top, 3 in the bottom, 2 in the top, 2 in the bottom. And so all I'm left with here is square root 5 over 6a. I will double check that answer and then get back to you on that. Okay, final question, question 9. So, show that the area of PQRS is that. Sorry, we're looking at the first part first. Find the intercepts of the graph F, okay? So the x-intercepts just where y equals 0. So if we set y equal to 0, we're left with 9 minus x squared. And so therefore x squared equals 9. And so x equals plus or minus 3. Not just plus 3. We need to remember that a negative times a negative equals a positive. If you want to use the language of primary school. So that's part A. Part B, hence showed that the area of, well not hence, showed the area of PQRS, so that's this big square there, will be 18b minus 2b cubed. Well, the key here is that we need to find out what the length of the base is and what the height is. So the area of PQRS is base times height. Well, the base, that's the easy part, that's just going to be 2b. The difficult part here is what's my height going to be? And so if I'm going to do it in terms of b, I know that this here lies on the graph of f of x. And so in fact that value there is just f of b. Well, what's f of b? Well, f of b is just going to be 9 minus b squared. And so therefore PQRS is going to give you 18b minus 2b cubed. Part C. Hence find the value of b such that the area is maximum. Well, we need to find the differential of that function in order to do that. So the differential of the area, so let's go d of PQRS over d of b, because with respect to b, would be 18 minus 6b squared. So then that equal to 0 to find my maximum. And then taking 6b squared over to the other side, I'd get b squared equals 3. And so therefore b equals the square root of 3. So at the square root of 3, the value for b is maximum. So if we then plug in that value for square root 3, oh no, they just want the value for which it's maximum, they don't want to find the area. Okay, fine. So it's just square root 3. That's it, done. Okay, part D, it was good that most people, having not gotten B and C, got full marks on D and E, which shows that we are looking through the questions, and that's good, because you can gain full marks on later parts of a question, even if you don't get earlier bits. So consider the function g of x equal to that. Show that when the graphs f and g intersect, you get that. So, well, g of x we're given is x minus 3 squared plus k. And we're given the f of x earlier. 9 minus x squared, that's f of x. And so let's just solve that. So multiplying out the first bracket, I get x squared minus 6x plus 9 plus k equals 9 minus x squared. Well, there's a 9 on both sides, so let's get rid of those 9s. And then if I take the x squared over to the other side, I get 2x squared minus 6x plus k equals 0. And then dii, given that the graphs of f and g intersect only once, find the value of k. So if they intersect only once, it means that when they're equal to each other, they can only have one solution. So a quadratic with only one solution means that b squared minus 4ac is equal to 0. It's because only one solution, only one solution. Or a repeated root is what we're going to get. And so in our case, we need 2x, value for b is going to be minus 6. So minus 6 squared minus 4 lots of 2 times k equals 0. And so therefore 36 minus 8k equals 0. And so therefore 36 equals 8k. And k would be equal to, well, 36 over 8, which is 9 over 4, or 4.5. 9 over 2, sorry, which is 4.5. Great, and that's the paper done. I will now have a quick look. Oh no, part E. Oh no, that is part E. I will now have a quick look over my answer for question 8 and just double check that I was right there, because for some reason that just doesn't look familiar.